Good day, everyone. Welcome to our discrete mathematics class. So last time we had a discussion regarding mathematical statement. Just a quick review. So when we talk about mathematical statement or proposition, this is a declarative statement that is answerable by either true or false. So atomic statement or proposition is a simple declarative statement that can no longer be divided into smaller statements. So molecular statement or proposition is a declarative statement that can be divided into smaller pieces. It is somewhat like a compound statement in a formal English language. So here are some examples of mathematical statement. We have here the first example of atomic statements. Telephone numbers in the USA have 10 digits. This statement is simple and can either be answered either true or false. If you are not familiar with the composition of the telephone numbers, you might end up guessing. Some might say yes, it is true. Some might end up guessing no, it is false. Therefore, from that statement itself, you might end up with two options. Either the statement is true or false. So from this example, this is considered as an example of an atomic proposition or atomic statement. So for number 2, the moon is made of cheese. This is a proposition with the truth value is false, considering the real composition of moon. For number 3, 42 is a perfect square. This is again a proposition. And when we look at the truth value is false. Because perfect square, the examples of the perfect square is 1, 4, it is, we got 4 from 2, by multiplying 2 by 2 times 2, we get 9, by multiplying 3 by 3, or 3 times 3, and 16 when we are going to multiply 4, or 4 by 4. So those are examples of perfect square. It's 1, 4, 9, and 16. 42 here is not a perfect square, therefore the proposition is a false proposition. So for number 4, every even number greater than 2 can be expressed as 2, as the sum of 2 primes. This is again a mathematical proposition. If we examine the statement, there is an implied value that is being specified. Every even number greater than 2, meaning it could be 4, 6, 8, 10. This can be expressed as the sum of 2 primes. So we have to verify 4 is greater than 2, an even number greater than 2. So we can get 4 by adding 2 plus 2. 2 is a prime number. When we talk about a prime number, this is a number that could be that is a multiple of 1 and the number itself. So 2 is considered as a prime number. So 2 plus 2, therefore, it is 4. 6, it is greater than 2, and it is an even number. Again, this can be expressed as the sum of 2 primes, 3 plus 3. Same as for 8. This is again an even number greater than 2. This can be expressed by the sum of 2 primes, 3 plus 5. And 10, okay, can be expressed by the sum of 2 primes, which is 3 plus 7, or 3 and 7. Same for 12. No? This is an even number which can be expressed, no? From the sum of 2 primes, 5 and 7. So then again, from the example, okay, we have verified that the statement is true. Therefore, this is being considered as a true mathematical statement or true proposition. The next example is 3 plus 7. Again, this is a mathematical proposition. However, this is a false proposition because 3 plus 7 is 10. No? So next is the example for not a proposition, not a statement. Number 1 here, would you like some cakes? This is not a proposition because this is an interrogative statement. You are asking questions. Second one, or second example, the sum of 2 squares. From the phrase itself, we can no longer tell that this is a statement or proposition because the truth value is unknown. Something is missing. If that would be the case, then this is not a proposition because we cannot decide whether it is true or false. Another statement, 1 plus 3 plus 5 plus 7 plus that plus 2n plus 1.1 and so on and so forth. This is not a proposition because the truth value is unknown. Something is not known from the statement. Another example, go to your room. This is not a proposition. This is not a statement. This is an example of an exclamatory statement. The last one, the reason the sentence 3 plus x equals 12 is not a statement is that it combines or it contains a variable. Depending on what would be the value of x is, the sentence is either true or false. But right now, it is neither. One way to make the sentence into a statement is to specify the value of the variable in some way. This could be done by specifying a specific substitution. For example, 3 plus x equals 12, where x is equals to 9. So definitely, this is a true statement. Okay, that makes the statement a true statement. Or you could capture the pre-variable by quantifying over it, as in, for all values of x, 3 plus x equals 12, which is false. But still, we can classify that the statement is a proposition or a statement. So, in this case, we have here an example of a molecular statement. You can build more complicated or more molecular statements out of simpler atomic or molecular statement or proposition using logical connectives. For example, this is the molecular statement. Okay, telephone numbers in the USA have 10 digits, and 42 is a perfect square. So this is an example of two atomic statement in our previous example, which is combined using illogical connectives and. So these are the logical connectives: and, or, if, then, if, and only if. These these particular logical connectives are called binary connectives. The other one is the unary connective, which is not. So we have here examples of molecular statement. Considering P as Sam is a man and Q as Chris is a woman. So the first molecular statement example is Sam is a man and Chris is a woman. When we have to express this in the well-formed formula, considering as what I have said a while ago, that P here, okay, sorry, so we have here so I have to consider this na Sam is a man is the P, okay, so I have to express this one, ito yung si P, okay, ito si Chris of a woman, Q. So take note guys, P and Q are propositional variables, or sometimes called as sentential variables. So from this molecular statement, we can express P, okay, and Q. So that is Sam is a man and Chris is a woman. So this is the well-formed formula for this particular molecular statement. The second example is Sam is a man or Chris is a woman. So from the second example, when we are going to convert it into a well-formed formula, that is P and or, okay, Q. So this is the well-formed formula for the second example. For the third example, we have here, if Sam is a man, then Chris is a woman. So if then, the well-formed formula for if then is, we have here P and then this one and Q. And the fourth example, Sam is a man if and only if Chris is a woman. So when we are going to translate this molecular statement into a well-formed formula, this is P, so may arrow yan, dalawa, okay, that specifies if and only if, then Chris is a woman, Q. So this is the well-formed formula for the fourth example of our molecular statement. Sam is a man if and only if Chris is a woman. For the last example, Sam is not a man. No? So this is the when we convert this one into a well-formed formula, this is not P. Okay, so this is the well-formed formula for this particular molecular statement. So take note of the logical connectives and the well-formed formula. These molecular statements are, of course, statements, still statements, so they must be answerable or considered or can be decided either true or false. The absolute key observation here is the truth value. the molecular statement achieved is completely determined by the type of connectives and the truth values of the parts. So we do not need to know what the parts actually say, only whether those parts are true or false. So to analyze logical connectives, it is enough to consider the propositional variables, or as what I have said a while ago, sentential variables. So usually capital letters in the middle. So we have here our common sentential variable or propositional variables. P, Q, yeah, R, S. So this is the common sentential variables or propositional variables that we use to express molecular statements into a well-formed formula. So we think of this as standing for usually atomic statement, but there are only two variables, two values for the variables can achieve, either true or false. So we have to make use of the symbols. This one, take note of the symbols. This is the well-formed formula for P and Q. This is being read as P and Q, which implies conjunction. This one, P or Q, is being read as P or Q. This is the well-formed formula that specifies this junction. The other one is P, FP, then Q. This is the symbol which implies P follows Q, or P implies Q. Now this can be read as if P then Q. This is called sometimes as implication or conditional. The other one, or the other well-formed formula, is this one. Okay, this is being read as P if and only if Q. So this specifies by conditional. And the last one is not P. This can be read as not P, which specifies negation. So take note of the well-formed formula. Okay, these are actually the well-formed formula. You have to take note of all these things, because as we go along with the statements, the several examples, we are using the well-formed formula to specify a certain mathematical statements. So take note again in our example a while ago. Okay, so using the logical connectives, if we are going to convert this molecular statement into a well-formed formula, if our first sentential variable P is equals to Sam is a man and Q, Chris, is a woman, then P and Q, okay, this one is P or Q. The third one, if Sam is a man, then Chris is a woman. So this implies P to Q. So the other example, Sam is a man if and only if Chris is a woman. So this implies, again, the well-formed formula is this one. And the last one is not. Okay, this is not, sorry, erase muna natin. So we have here not okay, to specify not B. Okay. So again, do not forget the well-formed formula, the logical connectives, the symbols that is being used, and the sentential or propositional variables. So last meeting we had a quiz, so let us see if everyone got the correct answer. So let us examine from the first question. Manila is the capital of the Philippines. So this is a true proposition. Yeah. Jakarta is the city in Canada. Again, this is a false proposition because as far as I know, Jakarta is one of the city in Indonesia. X plus 1 is an odd number. So in this question, which one is not a proposition? So choice number 3, x plus 1 is an odd number. This is not a statement because there is an unknown variable, unknown value for variable x. Therefore, we cannot actually say that this statement is true or false because something is missing. Choice number 4, 5 is an odd number. This is again a true proposition. Then another choice is 10 minus 5 is equals to 5. Again, this is a true proposition. So for this question, the correct answer is x plus 1 is an odd number. This is not a proposition. So for number 2, which ones are not proposition or statement? So in this example, choice number 1, Rodrigo Calapan is the best president that Philippines ever had. So definitely, this is not a proposition, because of the word best. If the statement goes like Rodrigo Calapan is the president of the Philippines, definitely this is a statement, a proposition, a false proposition. However, because of the word best, Rodrigo, okay, we cannot decide whether the statement is true or false. Why? Because in the first place, he was never the president. So if we have to make comparison in the statement, we have to see to it that we can decide that the statement is either true or false. How can you say that he is the best or the subject is the best when he is not, or in the first place, he is or he does not belong to the database or to the databases of the president? So again, if we have to make a comparison in the statement, we have to see to it that we can decide that the statement is true or false. We have to see to it that it is present in the database. Otherwise, it becomes null or void or unknown. The other choice is, are you a student? This is clear, no? This is not a statement. This is an interrogative statement. The third one, if x is greater than 0, then x plus 1 is an even number. There is no unknown here. There is an implied value for x which is greater than 0. So it can be 2, 3, 4, 5, 6, 7, etc. Then 2 plus 1, just to cite an example, is an even number. Therefore, choice number 3 is a proposition. There is an odd number between 4 and 7. Again, this is a true proposition. Okay? Then, the last one, if x is an odd number, then x plus 1 is an even number. This is again a true mathematical proposition because there is an implied value for x, which is an odd number. Odd number. It could be either 1, 3, 5, 7, 9, 11, etc. So for question number 2, which ones are not a proposition or a statement. So the correct answer here is Rodrigo Calapan is the best president that Philippines ever had. And are you a student? For number 3, find which of the following sentences are propositions. So for choice number 1, Pascal belongs, or Pascal language belongs to high-level programming languages, is a true proposition, while the first computer appeared in the 18th century is a false proposition. Therefore, for this question, we have 2. Choice number 1 and choice number 4 as a statement that can be considered as a mathematical statement or mathematical proposition. Choice number 2, drink carrot juice, is an exclamatory sentence. Therefore, this is not a statement. Is there life in Mars? This is an interrogative sentence. Therefore, this is not a proposition. For number 4, find which of the following sentence are propositions. So we have to study each choices here. For the first choice, any square equation has real roots. So definitely, this is a valid proposition. For choice number 2, triangle ABC is similar to triangle A prime, B prime, C prime. First and foremost, when we say that it is similar, triangle ABC is similar to triangle A prime, B prime, C prime, when the 3 angles of the first triangle are congruent to the corresponding 3 angles of the second triangle, and the lengths of the corresponding sides are proportional. Therefore, we still have to determine whether it is congruent or not. And it is not clear in the sentence whether they are congruent or not. Therefore, this is not a proposition. There is something missing. There is something missing with regards to the truth value. It is not true that there is no water on moon. So again, this is a valid proposition. All hail the Olympic Games. This is not a proposition because it is an exclamatory statement. The last one, a sentence is written on a sheet of paper. This sentence is false. Is it a proposition? This sentence is false. This is a declarative statement, which is an example of paradox. When we say paradox, a seemingly absurd or self-contradictory statement or proposition that when investigated or explained may prove to be well-founded or true. However, apparently, there is no truth value assigned. What particular sentence? So we cannot decide whether the statement is true or false. Therefore, this is not a proposition. So that's it. I hope now it is clear to each and everyone what proposition or mathematical statement is, what is atomic and molecular statements, and on how to determine whether it is mathematical proposition or not. So that's all for now. Thank you and good day once again. Stay safe.